boom, they decided to create a new architecture. This new architecture is all based upon the concept that, if I remember correctly, Tomasz, you touched upon the JSI, the JavaScript interface. And the idea is to remove this like one bottleneck by having an interface that allows for direct communication between the native and the JavaScript sides. All of a sudden, you can directly invoke the other realm from each other. This is thanks to the magic of C++ that works basically everywhere. Just to set the scene, this is what the current architecture of React Native looks like. We call it the old architecture, or also paper. I don't specifically remember why we called it paper. I think it was like an in-joke because every internal Facebook project needed to start with an F. So like when React had the new engine that was fiber, and because the new architecture uses that, a fabric is made of fiber, so they called fabric, the new architecture is called fabric, and so they were like, okay, what's worse than a fabric? And they were like, oh, okay, then let's call the old version paper. So this is like, I think this is the right reason why they were, you know, developers, the two hardest things are fixing bugs and naming things. This is just like one of those things. So the core concept to know about the old architecture is the bridge here. So as you can see, what we have on one side is the JavaScript thread. On the other side, we have the UI, the native thread. And to communicate these two sides, we're relying on what has been called, again, naming is hard, the bridge. And what this bridge actually is just a message queue made with JSON messages. So anything that wanted to go from one end to the other, so for example, you write your JavaScript code, and the JavaScript code says, when the user clicks a button, invoke this method, what happens is that the native side needs to send a message to JavaScript, then JavaScript needs to say, okay, this event happened, now do this, and then it needs to send something back to native. And by doing that through JSON, first off, it means that everything goes through the same communication channel. So you have a lot of messages going constantly back and forth. And the other thing that you get is that the two realms are not really aware of each other. They just have a bunch of JSONs that they need to take, untangle, and like, okay, in here I have some stuff that arrived from here, but I don't know anything about the other side. And as you can imagine, having just one communication channel means bottleneck. Simple as that. So what happened is that, boom, they decided to create a new architecture. This new architecture is all based upon the concept that, if I remember correctly, Tomasz, you touched upon the JSI, the JavaScript interface. And the idea is to remove this like one bottleneck by having an interface that allows for direct communication between the native and the JavaScript sides. All of a sudden, you can directly invoke the other realm from each other. This is thanks to the magic of C++ that works basically everywhere. So yes, we're introducing another language, a low-level language like C++, but it's really that powerful. And to be honest, C++ has already been used a lot in big production apps for cross-platform code. Even before any actual cross-platform solution, certain big production apps would use C++ as like this code that would basically just run anywhere, from the fridge to your mobile phone to whatever cloud service provider. On top of this JSI, we have these two elements. One is called Fabric, the one that caused the paper thing to happen, and the other one is turbo modules. So Fabric is basically the part of the new architecture responsible for UI. So basically, it's like the new version of view managers, to keep it very, very simple. But again, because it leverages this powerful new feature called the JSI, the messages are much quicker, and we can have priority queues. So all of a sudden, because not everything needs to go through JSON, you can have high priority refresh commands, for example. So the classic problem of like scrolling a list and seeing the white flashes, that shouldn't be there anymore. Turbo modules, similarly, is for the native modules. So let's think like Bluetooth, for example. And what these allow in general are things like lazy loading of the native modules. All of a sudden, because you know when you're going to need something, you're going to invoke it directly. You don't need to build up all the native modules ahead of time because you don't know when you're going to actually need them. And also, again, more direct communication. And because C++ is the middle layer, everything needs to be fully typed. So all of a sudden, you not only can make sure that whatever you pass across is correct, but also more precisely typed.
So finally, React Native doesn't show warning about to load a new native module in async.
Yeah, I guess.
When you forget to put recursive
Oh yeah, absolutely. Yeah, I mean that's the idea, right? That's the plan. To be clear, it's still experimental. As Umberto was saying, it's been like made public, quote unquote, since '68. From 70 and 71, it's been more easy to use. In 72, actually, we're going to have a new, what is called an interop layer. We're going to touch on that in a bit during the questions. And overall, here's a quick recap of like the old, the new, and the main changes, or like the main differences. I think we can leave this one up, maybe.
Yeah, sure.
Yeah. Why not? Sure. Do you want to start us with the questions then?
Okay, yes. The first was, what excites you about this new architecture?
Yeah, so for me, this is mostly like enabling more capabilities, especially for React 18. But even except that, I think one of the nice things in Fabric is that it also separates like the rendering engine from the core part of Fabric, which is written in C++. But the rendering engine is basically like a little bit a separate thing. For example, in the old architecture on iOS, the rendering engine was tied to UIKit, which makes it not possible to basically use the old architecture with other view rendering frameworks like SwiftUI or Jetpack Compose. So of course, like with Fabric, it would be much easier to just replace that small part that takes care of rendering views, and we can maybe bring React Native into things like WatchOS or even like iOS widgets where you need to use SwiftUI for making your app.
Widgets are more interesting, also WatchOS.
Yeah.
I think.
So about me, I think that the most exciting part of the new architecture, kind of similar to what Tomasz was saying, like the fact that it enables so much more to be possible. In particular, all these new features that are coming that have arrived through React 18, so like concurrent mode, like suspense, like all of these things were basically made with React Native in mind. Mm-hmm. So the idea that now finally once we switch on the new architecture, we can leverage all those extra features and create more performant and more responsive apps. That to me, I think it's going to be huge once, like, let's say next year, we're going to be more used and we're going to be more like, probably all already on the new architecture, or like most of us, I hope.
Yeah, sure. Okay, for me, both what you said, but also, for example, CodeGen, because in a software agency, when you have a team and the team works with JavaScript, okay, TypeScript, but sometimes the team, okay, so the red line under one props, for example, leave it and run the project. Mm-hmm. But now with CodeGen you cannot effectively, because it's built also in C++ with the same type, no?
Yeah, actually we forgot to mention CodeGen because it's kind of like a separate tool that enables some of these features to work even better. Basically the idea is that these C++ interfaces, you can use them to generate the JavaScript interfaces and vice versa in a way. Well, I think right now, specifically, CodeGen is doing from JavaScript. Like it takes your TypeScript code, and from that it generates the Android and the iOS interfaces. But yeah, it basically introduces this automation layer that removes, well, on one hand, it kind of removes the need for the native developer to, or like the React Native developer to know too much about the native. Yeah. You can kind of trust it to fix things for you. And yeah, also like ensures that the types are correct. It has some limits, as Tomasz was saying in his talk, like typed arrays are currently not
Not
viable.
supported.
Yeah, but yeah, truly CodeGen. Another interesting thing about the CodeGen, and then we can move to the next question. I feel we're going to go so over time. But one interesting aspect is that it also creates an easy tell for when you do an update and that update touches native code. And let's say you have a CI system, you trigger CodeGen on every new commit, and then CI says, okay, did the new CodeGen run change any of the native interfaces? If not, you can do that update as an over-the-air update, which is incredible because, of course, like one of the main things about React Native is being able to have this much higher pace of releases and not having to, go through the review system every time. You can just like push a new JavaScript bundle, download it, and like rerun the app with the new code. So like, I think that once people start using that, it will make like apps be so much better, so much quicker, because all of a sudden you're like, oh, right, all of these changes, I can just go for it and like deploy them right away.
Yeah, it's like a contract between JavaScript and native. So like if something like changes, then the contract is
It's more safe.
yeah.
Yeah, absolutely.
Then another question: what are the problem of the old architecture? For example, in my experience, I had to implement infinite scroll in a flat list, and after not too much elements, 100, 150, like this, starts to be
Super
lag,
laggy.
but also maybe was I have to improve something, but start with the whole column.
Yeah,
Make something
basically
strange.
the messages on JSON were so bottlenecked that native was receiving old commands and was showing them while receiving new commands, so things were swapping around. Interesting.
Yeah, then you come back and all it's okay.
Yeah, I think flat list is probably like the one that everyone kind of did. Yeah, I think flat list is probably like the one that everyone kind of did.
But
It's
I heard in this day that exists also flash list.
Yeah,
That's
that's
interesting.
but the approach of Flash is like different. Like it tries to visualize like all those elements from the list, but it really like does it on the JS side. So like on the native side, there is not like too much code on the native side. So like basically, it's very nice idea, but if you want to make it like as it should be, then it should be rather like move this code to native to make it even faster. So I believe with Fabric, it might be possible to even improve how flash list behaves.
Yeah, because I cannot go through this step, but I saw 10% faster in a UI thread, for example. It's written on the site, so I thought that was more native than JS in this case.
So just to be clear, Flash List is a library published by Shopify. They do shopping stuff, but they do it for you, right, more or less?
E-commerce.
E-commerce, yeah.
Yeah.
Something. They do something, but they're great. They're great at it. And also they do a lot of open source, like this Flash List, which is like a drop-in replacement. So, but yeah, like it's performant and it works in paper. I think they're struggling a bit to migrate it actually to Fabric. But yeah, from my end, I think that probably because I come from like a big core perspective, like at Microsoft, one of the things that we look a lot at is like startup time and bundle size. And I think that with paper, especially for example, with this fact of like having to load everything at the start for the native modules, like the overhead of spinning up a React Native instance, even in a brownfield app, is high. So we always need to really evaluate all the trade-offs. So like, I really think that once we will be able to all migrate to the new architecture, like that will disappear and that will help a lot with some of these key metrics that we have set for ourselves.
I think maybe I can also say what was good in the old architecture, but years ago, because like also one of the reasons why the bridge exists was for debugging reasons. So like some years ago, like the only way to basically like put some breakpoints in your JavaScript code and just make it easier to debug your JS code, we used to use remote debugger. So it basically opened like Chrome inspector and so on. But it had some problems, especially that this JS code was not run on a device, but in the browser. So like the bridge allowed like the asynchronous communication between your device and the JS engine in your browser. So in that terms, bridge was good for that. But right now, because also Hermes is there and it's widely used, Hermes has its own, or maybe like the other way. There is also something called Chrome Protocol Inspector, which is like completely like different thing that's the remote debugger. And Hermes implements this protocol, so it's now easier to just use the dev tools from Chrome, but it still runs the JS code on your device. So right now, basically, we don't need the JSON serialization and like to send those messages to the browser, because the browser only like needs to know like what's your view hierarchy, what are the variables. But yeah, right now it's very good, and even recently, and like my friend from Expo team, we released extension to VS Code where you can also like just breakpoint wherever you want, and it works like pretty well. So you can see all the variables, and yeah. So we don't need the remote debugger no more.
Yeah.
So we don't need bridge no more. So
yeah, we're good. It has done its time. We're like, thank you for your service.
yeah.
We want to talk about Flipper instead.
No.
How to debug normally without Flipper, but with Hermes.
Okay,
Exists some way.
Okay, so we're going a bit off topic, so I'll try to keep it short and sweet. So first off, there was a talk at App.js from Cedric from Expo about like some of the improvements that Expo is thinking of when it comes to debugging. For Flipper itself, we already have the Road to 73 discussion open, and one of the key discussions that we're having is the deprecation path for Flipper. There's an RFC that is currently discussing what we want to do with Flipper. Pretty much what's going to happen is that we will at least take it out from the defaults so that we don't like enforce it on everyone, while we work with some like partner teams like Microsoft, Meta, Expo. We're all working together on this to sort of like figure out a better approach for debugging. So it's something that is actually being worked on.
It's a work in progress.
Work in
So
progress.
we have only to wait.
Yeah, there's an RFC, you can go there and read it.
For now, we disable Hermes and continue to use normal debug from Chrome.
Yeah, I mean,
This is
it's one of the alternatives.
Real. Next question. Do you already tried to put new architecture in some applications? Are you approaching?
How am I approaching it? It's, so for example, what I did so far, because we again, at Microsoft, we're really looking at this as, oh, okay, this will help a lot with some of our core metrics. The way we're approaching it is, let's create like an experimental scenario. Let's see what works, what doesn't. And then once we have figured out that scenario, then let's start looking at like, how can we actually put it into our production apps. So what I've done so far is one example app where I tried all the combinations of new architecture, old architecture, just Fabric, just Turbo modules, like switching them on and off with a series of libraries. So a library that says that it supports the old architecture and the new architecture, library that only works with the new architecture, like tried all these combinations, and it's an open source repository, you can look at the table, to kind of like understand what's the cost of migrating to the new architecture. One thing that we mentioned earlier is that in 72 there's going to be what is called an interop layer. And this means that even libraries that are not built for Fabric, they will work on Fabric with some custom setup. like you will have a config file, you just need to write some things in there and then it will work. And this is huge because all of a sudden, like even my investigation kind of like gets outdated because turbo modules by default right now, they are backward compatible. So like if you have a Rack native Bluetooth, even if it's not like supporting turbo modules directly, because it's a pure native library, like it doesn't give you any UI elements, that will automatically work even if you turn on the new architecture. For Fabric, up to 71, that wasn't the case. So that's why I did the entire investigation of seeing, okay, realistically, how many libraries are we like stopped by when we want to migrate? But like now with 72 with the interop layer, we'll be able to like much more easily just like turn it on, create this interop configuration, and then like see what happens. Like, does everything work? Are we seeing the improvements that we want? So this is more or less how we're approaching it. So basically, we're experimenting first. I don't know if at Expo.
Yeah, so at Expo we also have an example app with like some examples for each of Expo SDK library. So we also have like a separate app for old architecture from the new one. So we are testing almost the same code against those two apps. Yeah.
So because we have maybe to say that Meta didn't want to make new architecture to improve performance, no?
Yeah, so I think that basically what happened is that Meta, like in their internal products, for example, the Facebook Marketplace tab, like they are already on the new architecture. And the way they went through it, like it took them 3 years while constantly working on the new architecture to get to that point. And one of their key like measures of success was no regressions. So yes, it doesn't necessarily mean that all your code will, like you just switch on the new architecture and everything will work faster automatically, but it will at least perform as it was before, but then all of a sudden it doesn't have that like higher like stopping point of the bridge being the bottleneck. You can go past that, and hopefully, you know, a year from now, once it's more broadly used, especially from 72 onward, people will have already started building things on the new architecture so that things will be better, basically. So it's a common effort, and we all need to kind of like help each other getting there a bit.
So we can come to the question, is really needed?
To migrate?
To migrate, yes.
So when I would like to like start a new app right now, that would be like, okay, I would try the new architecture. And it's like in case I hit some problems or like a library that doesn't support it, or like even the interop layer, it may not work for some cases. So in that case, I would just try to contribute to this library and like, yeah, try it like to fix it on my own. So I would recommend that to everyone, basically. So.
For example, Software Mention has a lot of libraries already in the new and old architecture, like reanimated.
Yeah, all the Software Mention ones, and all of the from Expo SDK as well. So I think we already have like a bunch of good set of native modules and native views that most apps need. I think we are ready to go.
Yeah, that's lovely.
I tried a few weeks ago, but React Native Just Render doesn't work on new architecture. But this was maybe 1 month ago. Didn't
Which one?
work. React Native Just Render.
Just your Rendler.
Just
Okay. But what was the version?
71, the version of React Native, and the latest, but not beta. Maybe was this the problem?
It's just your Rendler.
I have to try with
I'm
beta.
sure it does support.
Without?
So yeah, I think like after or maybe during the weekend, you should try.
Now I can write it
Or you can send a
directly to you.
PR.
So now at night I write to you too. Why?
Sure.
I want to try.
I actually want to hear like your perspective from like you know, working with clients. Like, how do you even like justify, hey, we should be moving to the new architecture? Is it something that you're already kind of exploring? So, sorry.
I explore only surface. I wanted to try also with client, but I think I need 72.
Okay, yeah. That
Because
makes sense.
also it means one library to backward compatibility of Fabric and nothing works. So, or the app is like proof of concept. We could try with our wallet, but React Native Quick Crypto, for example, doesn't work. So we came back to the old architecture.
So 70 is going to be this month, I guess.
Next
right?
Wednesday. Next
Yeah,
Wednesday.
so
This coming Wednesday, we should be good to go. We wanted to do it like this Wednesday, but then we figured out there was a regression on some UI Android things, so we had to really I literally spent the entire Monday trying to figure out what was going wrong. Gabriel, which works for Expo, he's a great guy. He submitted a couple of PRs. We managed to address everything, and also we managed to that problem made us realize there was another problem underneath, and we had to fix that for about 71 and 72. So right now there is a new release, R66 for 72, that should be the golden one. We shouldn't touch anything now. It should just work. And there's 71.11 where we've already fixed this other problem. But yeah, to kind of going back to your question about is it really necessary? Maybe again, because I'm an engineer, so I tend to be pessimistic. My answer is kind of it's not like we have an option, to be honest. If you think about it, if you have an app and you want to keep using it long term, for example, we've put React Native through React Native Windows in Windows 11. We put it we have it in Office, across all our parts. So Word, Excel, PowerPoint, all of those. That means that we are betting React Native long term. Maybe it's going to be a year from now, but at some point they will say, okay, we're going to switch off entirely the new architecture, the old architecture, sorry. So let's say by version 99 or something, they're going to be okay, this version onward paper is not going to be there. So you cannot rely on backward compatibility. You will just be on the new architecture. We know that the day will come. It's probably far away, sure, but because we know that the day will come, we want to be ahead of the curve and be proactive, because also if we hit problems early, it's easier to fix them, right? If a problem that we hit today was caused by a PR that was sent last month by someone from Meta, that person will still have kind of in their mind, okay, yeah, this is why I did it or how it changed. But if we wait a year to wait the very last minute to be oh no, now all of a sudden we need to turn on the new architecture and everything, we hit a bunch of problems, then these people that have done the commits or have worked on the code, maybe they don't even remember how, oh, that changed, I did it 12 months ago, I don't even remember how to address it, right? So we really want to be ahead of the curve and as close as possible to latest to really address the vast majority of the problems as soon as possible.
Yes, very good. And I think the time is...
we're close on time.
Yeah, we can conclude with the last question that is connected to the second question, if we want to be honest. But one thing that the new feature that is most important in new architecture, but this, I think, is for me. You said before is React concurrent features, for example.
Yeah, probably the fact that we are bringing all this extra power to the UI layer. That also means we can get, in a way, more parity with web, and that's actually something that we are exploring more broadly at Microsoft. So if you want to learn more, wait for September, React Native Europe. Me and a colleague of mine, we're going to do a talk where we're going to share a bit of some of the exploration that we're doing in making, React Native even more, React in general, more universal. So absolutely, the new architecture is going to enable so much that right now we cannot even do. So I'm really looking forward to that.
So also improvements for macOS, React Native macOS, React Native...
oh, yeah, of course we're bringing, that's one of the other things that we're going to work in the next 6 months. We're bringing the new architecture to both React Native macOS and React Native Windows, for sure.
Yeah, so this is the same as I said before, bringing React Native to other ecosystems, platforms, which Fabric really helps in doing this. So
Yeah, having access to C++ really opens the door to basically everything.
Yeah. Even right now, we can even run on Linux. Basically, there was also a talk on UpJSConf where Kudo presented that he was able to run React Native with Fabric on Linux.
That's awesome.
You can create a
On
site,
Raspberry
React
Pi,
Native everywhere,
basically.
React Native
Yeah.
also in the car.
Oh yeah, for sure. Like,
It's running. C++
I mean,
running. so-
some cars use web views basically for the HMI, so why not? Right.
My car uses Microsoft. Sync 4. This is like-
Really?
Yeah, for.
Okay. But yeah,
Anyway, we can conclude.
Yeah.
So,
thanks everyone.
thank you for attention.
Thank you for staying.